So we did day one. Now day one was all about setting up. Day one was all about setting up the computer and basically getting the built-in LED to flash on the Pico. And then day two was messing around with LEDs. So we got the 3 LEDs, red, yellow, or orange, or whatever you want to call it, and green. And we got to turn them on, and then we got to turn them off, and then we got to turn them on and got to turn them off. So I set some homework. Where I asked you to, out of the 3 LEDs, build the typical UK, well, I did say traffic light. I didn't specify UK, so that was a mistake on my part, but it's all right. Yes, I was just about to come to that. So I set some homework, right? Now, when we were streaming last time, on Monday, the advent calendar had about 4% stock. The following day it was sold out. So I did my bit. I did my bit for Pi Hut. You did. They don't have any. Yes, the advent calendar was sold out Tuesday morning. When no, not Tuesday morning, Sunday morning. I'm thinking it's Wednesday. It's not. It's Monday. Yeah, it had sold out on Monday because I was going to get me someone, but it had sold out. So. Well, the pies have been sold out everywhere for ages, to be honest. I mean, there is a dedicated website to find pies. You know, it's there you go, our pie locator, because I'm on it all the time. So, I mean, there's 3 come up. That's in the US. See, no 4s have come up in the UK for ages. So it's not just Pi Hut. It's not just Pi Hut. Well, a used Pi 4 goes for about 100 quid, I think, now. A brand new one's about 160. 4 gig. 8 gig, more than 200 quid. So, yes. So if you wanted to play along, I'm afraid that the calendar has sold out. You want a 02? Oh, you've got an 8 gig. Oh, no, I ain't got the 8 gig. I got the 4 gig. But I've also got a Pi 400 here. So, I'm sort of set. I've got the Pi 400 and I use that quite a lot. To mess around with. And you can get Pi 400s quite readily. You can get the Pi 400s. They're still in stock. And they're just as good as the pies, the regular pies. In fact, they're faster because they're overclocked. Anyway, so I set some homework where you had to simulate a traffic light system. So I created a homework channel. Hang on. Been learned. Yes, Docster. I've heard all about it. Oh, you're going to try and teach me so you can do Myriad? Oh yes, I heard about that, the course. Yes, I heard about that. Anyway, so I've created a homework channel in my Discord where all the people that have done their homework I have pinned, right? So we're just gonna have a quick look at how people have done them, yeah? So here we go. So this is GaryMeg's effort. Now Gary's done 2. He's done 2, right? He's a bit more advanced than the rest of us, so he's done 2. So Gary has all he's done is he's created a loop, yeah, and he's done a sequence between 0 and 4, yeah, and then he's testing using the case statement. So if you've never ever used a case statement before, it's called switch, or in VB it's select case. I think it's the same in JavaScript as well. Yeah. So he's looping. He's doing a loop between 0 and 4. Yeah. And then he's testing what the sequence is, and then setting the individual LEDs. So that will be stop, get ready to go, go, get ready to stop, and then it returns back to here. So if we run it, there you go. Stop. Get ready to go. Go. Now I think that's a bit quick, you know, but there we go. So it works, and it works well, and there's nothing wrong with it. Nothing wrong with it at all. Now, him being much more advanced than the rest of us, he's actually done one without a delay. Now I thought I was looking at this and I thought, yeah, okay, that's different. So basically, is emulating what we do in a game, where we were constantly doing the game loop, yeah? So this is constantly doing a loop, yeah? And he's testing a counter at specific areas. So less than 5,000 does red. Between 5,000 and 6,000 does the get ready to go. Between 6 and 11,000 does go. And then over 11,000 does get ready to stop. And then 11,500 it goes back round. So if we run this, so this is a different way of doing it. And it does do it. But have you noticed that the emulator's struggling? The emulator's struggling to run this at full speed because it's doing the loop thousands and thousands of times. Yeah, whatever. Right? And that's making the emulator only, well, on my machine it's running at 17%. John, check the highway code. Yellow means boot it. Oh dear. So this is actually running slower than the previous one, and that's because the emulator's doing the loop, right? So that is a different way of doing it. So we had a submission from SP, and he's done it a different again, but me and SP seem to be on the same sort of level, yeah. So I'm going to try and explain this. So he's setting up two arrays, right? One array has got the LED pin numbers in it. So he's got an array of LED pin numbers with red, amber, green, and then he's got a list sequence array, which is just a straight array, but the way when we look further down, he's grouping in threes. Yeah. He also has a timer and a sequence indexer. So he sets everything up. So he runs through the 3 pins, sets them to output, and then he's doing the loop. He's just doing the loop. So he's created a function, and we haven't talked about functions. I'm going to be talking about functions today. So just for those guys that have not done C++ before, he's done a function where he's setting the light. Yeah. So what he's doing is he's taking in the index, the light sequence index, yeah, which when I'm looking at it, between 0 and 9. So 3, 6, 3, 6, 9, 12. So that looks like it's between 0 and 9. Yes. So it must be 0 for the first set. So 0 for that set, 3 for that set, 6 for that set, 9 for that set. And then because he's taken the index in, so it's going to be 0, 3, 6 or 9. Then he's running through 9, 10, 11, 12. Or 6, 7, 8, 6, 7, 8. Yeah? And then reading that array and setting the pins. And then he's just looping round and round and round with an 8 millisecond delay between each step. So when we run it, everything is the same delay. But he does it, but it's a much more sophisticated way of doing it. And when I was looking at it, I was thinking, how? But it's all a singular array in groups of 3, yeah. So even though this array is just one big long list, he's actually grouping it into 3. Glad the intro's finished. I am going to start a stream without the intro, and you're going to miss half of it. I'm telling you, one of these days. So that's SP's version of doing the traffic light, right? So I think we had another one, didn't we? Yes, we had another one. SP. Oh, SP did another one, didn't he? He did another one. Is that the same one, or did he fix? Oh, he's done another one. Right. So this. Right. So this is similar to. This is similar to what GaryMeg did, but he's setting the light sequencing index. He's setting the light sequence index, which is then running that. So if I run that, so it looks like now he's got different timings. There we go. Yeah, so he's got different timings. Yeah, it is fixed now, mate. I've just run it. So this is very similar to how GaryMeg had done his, but as GaryMeg, he put all the instructions to set the he put all the instructions to set the LEDs at those points. As you're setting the sequence index, which then you use your set light to look at the array. I mean, I thought this was very clever. I've not seen this before. Now, that's a modular thing, I think, isn't it? Where's my cheat sheet? Is it a modular thing? Oh, remainder. Right, so it's the remainder. So he's dividing A by 3 and getting the remainder. A modular 3, it says remainder. Right, let's see what it says. Operation calculates the remainder when one integer is divided by the other. So, yeah. So I thought that was very clever, because you're dividing by 3 and then using the remainder to get your index. You're getting your index point. So that was very clever. So we've got one more, which was, I think, yes, 6502 Kebab. He's joined the fight. He's joined the fight. So he's done what I would class as the noob way, where you've just got one loop and you're setting everything on every step. Yeah? There's nothing wrong with it. It works. There you go, it's working. It works. There's nothing wrong with it. Yours will be available in 2024. Hey Phase, welcome. Stack bats. Noob theme fighting words. Well, don't get me wrong, right? Don't get me wrong, because I have done it as well. I've done it. Where's mine? There we go. Right, so I did 2 versions, yeah? I did 2 versions. There we go. So let me just rename this. Right, which is what I called the noob way, which is basically you're setting your outputs and then you're looping and setting the LEDs in one circle. Oh, Aston, stop it, you've been out, mate. He's been out. You've been out, mate. You've been out. Has Nico nicked your bed? Has Nico nicked your bed? Let me have a look. I don't know what you're moaning at, mate. No, mate, he's been out. Before. Out. He's been out, mate. It was out before the stream started because when I went down to sort Nico out because he'd fallen down the stairs. So I don't know what's up with it. I think Nico's in his bed. I think that's what he's moaning about. Well, he can sleep in Nico's bed. So it just loops round. So when you press play, all it's doing, it sets the LEDs for red, waits 5 seconds, sets the LEDs for ready to go. Sometimes they need more than one. Oh, all right. I will be back in a mo. Yeah, I was thinking that. I was at the bottom of the stairs and he's at the top of the stairs going, and? He wanted a drink, he went straight to the bowl. Right, so this was the noob way. This is the noob way, and I say the noob way, it's not detriment, it does the job. You know, I was taught I was taught by my father to always keep it simple. You know, when you're coding, always keep it simple. Yeah, and this does the job. It's simple. It does the job. Now, if there was a possibility that the traffic lights would change or something like that, then maybe something a bit more advanced. So here is my intermediate, as I call it, my intermediate version. Now, there is an advanced one, but I'm not going to show you that because that is we haven't been speaking about anything that I've done in there. But this is very similar to what SP did. This is very similar to what SP did. It was quite surprising that me and SP had a similar idea. It's not the same, but it's a similar idea. So I have an array with the traffic light pins in, right? I also have a traffic light sequence array, but the difference between SP's array and mine is mine is two-dimensional, as SP was one dimension. Mine is two-dimensional. So I have got a two-dimensional array with a set of 3 in, and then I've also got an array with the delays in, you know, the delays. So I do the typical setup. Now I've put in here, now there's this here, which allows you to find out how big your array is, so you can run through your array. So if your array changes size, your for next loop will change as well. So it's just me thinking of the future and stuff that potentially could change. And then I initialize the LED. So I've got functions called LED on and LED off, yeah? And then this is my loop. This is my loop. So I have a now, to be warned, I have documented this. I documented it in here, so don't panic. Don't panic. But I have a transition variable, right? So I have a transition variable, and the purpose of that variable is to tell the loop, right, we need to transition. Yeah. I've also got a current cycle variable, which is the how many loops we've gone through. What the current duration is basically how...
Ladies and gentlemen, 6502 Kebab has entered the chat.
Hello mate, hello. So I have got current duration, which is how long we wait before we do the next transition. And then I've got a state variable that records where what my current state of the traffic light is. Yeah. And so when I get to state 4, I revert it back to state 0, because state 0 is the red on. And then what I do is I delay for 1 millisecond, increase the counter, test if the counter is greater than our current duration. If it is, I flag that the transition should start. And so if I run this now, should end up, there's the red light. And it's 5 seconds, it moves on to get ready. 2 seconds later we go. And then it goes back to amber and then goes back to red. So this is my version, which is a bit more in depth. Me and SP were on the same sort of thought levels. As he was working out where he was in the arrays. I don't need to, because I've done the resistors. Pa. But that was what I called the intermediate version. That's what I would have expected out of a yeah, for me it's running at 100%, because in the loop I haven't got a lot going on. Yeah, as you know, with the others it was struggling. Yeah. So, but this is what I would have expected out of a seasoned C++ coder. Are all the links in the first stream? They are, but what I can do, mate, is I can put them in Discord. Let me just do that. So where's the Pico? There we go. It's why you did. Oh, because of the simulation running slow. But I've just shown you can do the same sort of thing, and it runs okay. Right. So let's open that. Right. So that's that. Yeah. The advent calendar is, which I will need, is that. What else? Oh yes, the programming book. That's that one. If you want to learn C and C++, that's that one. That's the official Raspberry Pi one. The Arduino reference guide, which we've just had a sneaky peek at, is there. What else? What else do we need? I think that's it. So let me just pin these. Let's just pin these. There we go. Right. So this like I say, this is the sort of intermediate level that I would have expected out of a who's on detention? A seasoned coder. Okay. Okay. How does the emulator know that you're using Python versus C? I think it looks at how the code's structured, because I think I've got a MicroPython. I think I had a MicroPython one open. I can't remember. Is that one? No. But this site does do MicroPython, because where was it? I think one of these was in MicroPython, I think. There we go, MicroPython. So it definitely does MicroPython, yeah? But by default it's C. There you go, MicroPython. I think it's probably on the extension. I mean, we could definitely we can definitely try it. New project. Oh, there. MicroPython on Raspberry Pi.
Oi, John, pay attention to chat.
Yeah, I saw it. Yes, I saw it. So if we grab we just run it. There you go. So you can actually follow the advent calendar as it stands, yeah? Because everything's in MicroPython. Hey, that's your trick. Right, so let's get out of that. Now I've shut it down, I didn't mean to. Let's get back into it. So I think we're still using this. I think. When is the stream Christmas party? I didn't know. I don't know. I don't know. I'm currently on holiday at the moment. I'm on vacation. I'm having at my house. What a great... What, everybody descends on my house. Oh dear. And always cake and drinks a shot. Always cake and drink a shot every time makes a mistake. That's not going to happen, because after one shot, that's it, I'm dead. I don't drink, so... yeah. I'm no Shalom, I'd be dead. If we're going to zoom it, then code a Christmas game. Yeah. It isn't going to be like Challenge Stream. I can't drink like he does. I can't drink like he does. Right. So I think we're still using this. So what I'm going to do is I'm going to make a copy of this. So I'm going to make a copy of this. I'm going to change it because now we're on day 3. We're on day 3. So let's see. Right, let me get rid of that so we can delete that. And we're here, so we'll just rename that. So day 3 activity 1. Get everyone in a stream on Zoom. Well, we could do that in Discord, can't we? We could do that in Discord. We could get everybody on Discord doing. We could definitely do that. Can everyone be on cam in Discord? I don't know. I've never tried it. I know I've seen 4, but I've never tried it. But yeah, Zoom could be done. Right. So I haven't seen day 3. I haven't seen day 3, but by the title, it looks like we're going to be messing around with buttons. So where's my advent calendar? Here it is. So, day 3. Oh, better get that. Just got that just in case I need it. I actually ain't watching it. You saying your missus is on OnlyFans? Right, so day 3, we have got buttons. We have buttons, cables, and a breakout board. That's what we got. Day 3. So it's all about buttons. So let's see what we're talking about. Right, so we have one mini breadboard. Yes, we do. We have 2 buttons. Yes, we do. Sorry, 3 buttons. Do we have 3 buttons? Hang on. Let's empty the contents out in the box. Oops. Come on, out you come. This is where I break a button. And nothing's coming out. Come on. There we go. Oh, everything's all tied up. 1, 2. Hey, I'm missing a button. Oh, no, I'm not. Tell a lie. No, I'm not. I can't see for any. I can't. Oh, this isn't a right mess. So, we have 1 cable, 1 breadboard, 3 buttons. Right, so what we got to do? What do we got to do? Right. Today we're programming the buttons in your box as input for the code. We can easily use the code to trigger the program to do things such as counting. Okay. Most buttons are very simple. Just connect the circuit together and it sends a signal to the Raspberry Pi Pico via the chosen GPIO pin. You could do the same by simply touching 2 wires together, but of course buttons make it far easier and more friendly. Right, okay. We are going to use the mini breakout board as the little controlling pad for your project. as we're going to make use of the LED circuit from yesterday. It's a handy part to have in your growing stash of bits. Yeah, I'm getting a growing stash of bits, I'll tell you. Don't forget, best to use opposite corners with the buttons and put them across the center channel. Is that why this thing didn't work first time round? Hang on. Oh yeah, I put that across the center panel. Yeah, that didn't work first time round because I didn't put it across the center panel. Right, where are we? Oh, and the button caps. What button caps? Oh, they're already on. Okay, they're already on. Right. As always, first you need to disconnect the Pico from the computer. Right, we're doing that. Then grab the mini port and pop the buttons on each thing. Right, so we're going to do that here. So let me move that there. Right, zoom out. Add breadboard. So mini. There we go. One mini breadboard. So 3 buttons. Push button. Okay. Cool, that's massive. Can we resize these things? Well, that'll do there. Another push button. Oh, we can colour them as well. Oh, I didn't know that. And another push button. Put that there. Bit lopsided, but yeah. So I'll do that. Right, 3 buttons. What do we have to do now? I suppose we better do it on here as well. And like Wally, I am very, very wary of doing this. I break things, I'm a bit heavy-handed, so we'll do 2 individually. There we go. Ooh, get in. There we go. They're in there. Right. Now we need to connect a 3.3 pin of the Pico to the top rail of the board. Right, okay. So we need to create a line from the 3.3 there to there. So we'll do that. We'll make it red. And we'll move that up there. Floating pins, that's not good. It doesn't lock on, it only locks on the top. It only locks on the top. That's why I was wondering if these things could be resized. Because it only locks onto the top. Look, the bottom pins are not locked into the holes as the top ones are. So I don't know why it's doing that, to be honest, mate. Unless it's my browser. Right, what's next? Right, so now we need to connect the power to the buttons. Okay, So power rail to the button from there to there, there to there, there to there. So I'll make these red as well. Oh, we'll do it. We'll do it for real in a minute. The documentation says use Internet Explorer 4. No. Right. Now it's saying, okay, wire GPIO 13, 8 and 3. So physical pins 17, 11 and 5. Okay. So where's 5? There's 5. So we'll do that to the first one. What's the next one? 11. Do that to the next one. And 17. That can't be right, because 17's down here. Where's the diagram? Oh, right, okay. So physical pins. Right, okay. So physical pin 5 is GPIO 3. Right, let's shift that. Good job I'm checking, isn't it? 8. And 13. Oh, go away. My OCD's kicking in now. There we go. No, for your bottoms, best practice is pull down with the bottom, not pull up. Oh, we'll get there in a minute. Right, import. It says here, it says the GPIO pin must be on the opposite side of the button as the left and right sides are disconnected until the button is clicked. Right, we've done that. We've done that, and I made sure that they are on there. Right. So, activity number 1. Activity number 1. We are going to do a button test. First, simple test program for each of the buttons. Each button is wired, blah, blah, blah. Yes, we know. We'll use a 4-wire loop from what we learned yesterday. So the program keeps watching for the buttons that you can press forever, and an if statement. So we're going to start using an if statement to determine which button is pressed. Right, so we know about if statements. So, if the statement can be very powerful, blah, blah, blah. Let's first explain the code in pull downs. Pull downs. Your code below uses the pull downs. You can see this at the end of the buttons setup section as pin.pulldown. So why do we add this? When we use a button, we're sending a 3.3 volt to the GPIO pin to set it high. However, we need to make sure that the pin is low. in the first place, or our code might not be able to detect the change and or might trigger itself randomly. This is because the GPIO pins will pull down or pull up can be floating between 0 and 3.3. Pulling down the pin to ensure 0 volts ensures it's always low to start with. Sometimes this can be achieved by using physical resistors in the circuit. However, some microcontrollers such as the Pico have this functionality built in. Alright then, I did wonder about that. So, right, so we need to code. So, why are you... It is an INO file, isn't it? Yeah. Why are you not colorized anymore? You're not going to error? No, works. Okay. Right, so we need to... So we're doing pin 13. We're doing pin 13 first. So is it pin mode? Are we back into pin mode? Right, so not pin mode. Okay, so how do we tell it to pull down? Or is it? How do we set to pull down? Because it says input pull up. Okay. Looks like we've only got one thing and that's pull up. Okay. So, pin mode. Right, so let's do some definitions. Define button 1 is what was it? What was it? It was 3. Was it 3? 3, 8 and 13. Right. So we'll do button 1 is 3. 2 is 8. 3 is 13. Right, okay. So we're going to change this. So pin mode. So we're going to do button 1, yeah? Button 1. And it's input pull up, wasn't it? Like that. Let's put that. Let's put that in there. There we go. Pull underscore pull up. Yeah. Change your VC. Change your VCC to ground going to the buttons, and you'll then check for low, not high. All right, okay. Okay, so we have to change the way the diagram works because we're using C. Okay. So I'll leave that there. So there's a ground here somewhere, isn't there? There it is. To there. And so you're saying... move that. Oh, you can't do it, can you? That what you're saying? That what you're saying? Because they're doing pull down from positive to negative. We're doing the other way around, yeah? Last one is wrong. Okay. Yes, yes. Right, okay, so we are going to, we'll run that out. Oh, I thought this was VS Code, but it's not. Okay. INO, it is definitely an INO. Save. Right, so we're setting the button. And what are we doing now? Right, okay. Let's get rid of all this lot. And so we are looping. So, oh, what's going on here? Delay, 200. Delay 200, and then we're going if. Now, they have got this special command for button, so it looks like the pin has a special command. So we are going to have to do a digital read, yeah? Do we? All right. So we have to do a digital read of the pin. And so we're saying, is it equal to 1? And if we are, oh, the tab's not working. What are we doing? Button 1 pressed. Right. Let's see if that works, shall we? So it's button 1. Whoa! I've spelt that wrong, haven't I? So it's saying it's pressed all the time. That is because we're testing for high. We need to test for low now, don't we? Because we're doing pull up. It failed because the curly is on the next line. No, it didn't. Right, so it should. There we go. Button 1. There we go. Right. OCD error on line 29. Run again. Okay. So. There we go. So now we now know how to check for a button. Yeah. So we've done that. So what they're asking us to do again? Multiple button inputs. Let's add our other buttons to the code and change our if statement to make it that it watches any of them for being pressed. To do this, we need to set up an if statement. Okay. Independent ifs. Right. Okay. Independent ifs. So that's activity 1. So let's rename that. Grab that. New file. Activity 2.ino. Oh, that one works. That's weird. Right, so we're adding the other 3 buttons in. So 2, 3. So we're going to do that and that. And then we're going to basically that. So 2, 2, 3, 3. So that's effectively what they're asking us to do. Alright. So this is a case of whichever button we press should be recognised. Right, so button 1. There we go. Button 2. 3. Right, okay. You're lagging behind. That's alright, mate. It's alright. Activity 2. So now we've contest for the 3 buttons. So it looks like that they're using pull down in here, which means that we're testing for it to go high. But in C, in the C language, you can't do pull down. Looks like you can only do pull up. Can you do pull down? No. So it's only pull up. So then we're having to test for 0 because it's high, then it goes to low. And that's why we've had to rewire the diagram. Right, what's activity 3? That was a quick one. Activity 3, multiple buttons with else ifs. Right. What if you want to do something more advanced with our buttons? Maybe we want to ignore button 2 and 3 if button 1 is pressed. Do we want to do something else to happen if none of the buttons are pressed? Perhaps we need to change something to hold 2 buttons down at the same time. We could do many things by using if statements with additional else ifs. Alright then. so what are we doing here? Oh, so we're only allowing one button to be pressed at a time. Now I can't simulate 2 buttons on here when I run this because I've only got 1 mouse pointer. So that'll be interesting when we do it on this. But in fact, I suppose we should... Yeah. We'll do it on here first. Right, so activity 3 then. Right, rename that. And we'll grab this. Come on. Right, so else if. Now, else if is like, no, else if. There we go. That's what we need to do, isn't it? That's what we need to do here, isn't it? If that, then nothing. Right, what else are they asking us to put anything else in? No. So if button 1 is 0, then print it out. If it's not, then if button 2 is 0, print that out. Else button 3 is 0. But it won't, if when we do it physically, it won't be able to do all 3 at the same time. You don't need the INO in the simulator. Yeah, I can only press 1 button at a time, mate. I need to wire this up. Need to wire this up and do it physically. But it's going to be interesting because I'm not sure if the monitor works in VS Code because I've not been able to get it working yet. But I'm sure GaryMeg will be able to point me out. Right, let's run this. Let's just run this. Just make sure it still works. Because then we'll do it physically, yeah? So, button 1, yes. Button 2, yes. Button 3, yes. I suppose it would work on an iPad. No, mate. I've right click doesn't do it. Oh, can you? Oh, hang on. You can give the buttons a shortcut key like 1, 2 or 3. Really? Really? Oh, yes, you can. Okay. 1. Excellent. Let's do that. 2. 3. Well, that was naughty, wasn't it? Now it's done it. 1, 2 and 3. Right, okay. Let's run it. So, 1, 2 and 3. So, 1. 1. Yeah, right. There's 1, 2, 3. Right, here we go. Pressing 1 and 2. Ah-ha-ha! Nice. Okay. That works. Thank you, SP. That works. Thank you. That's a good one. I didn't know that. Nice. Right, okay. Okay, and I saw what it did in the attributes as well. But let's change those. So red, yellow, green. There we go. Because at some point I think the LEDs are going to be used because they mentioned it. Right. So activity 3 is that one. So activity 2 would allow us to press 2 buttons at the same time. Right, so what else are they asking us to do? Are we doing anything more? Oh, hang on. Now that you know what Elif and else does, let's put them to work whilst adding our LEDs back into the program. The code below checks if we held buttons 1 and 2 together. It does this by using the if statement and for 2 conditions. Okay. So if button 1 and button 2 are pressed, then green's on. If button 1 is pressed on its own, then amber's on. And if no button's pressed, red's on. Okay. Okay, we can do that. We can do that. Right, let's rename this. Hey, oh, we have a visitor. Hey, buddy. You alright? Whoa, 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 whoa. Back up. Come on, back up. Back up. Come on. You can't go under there. Too many sharp objects. Oh dear. Right. So I've renamed that. New file. Activity 4. Come on. Right then. So we are. It's saying if button 1 is pressed, if button 1 is pressed and button 2, okay. Does that work? Oh, it's not and, is it? It's oh, I do get my bitwise things. And it's that. It's that, isn't it? It's just the one. It's just the one. It's 2. Is it?
Oi, John, pay attention to chat.
Yeah, I was. Yeah, I looked at that. Right. Okay, it's 2 then. Right. So if it's you get stuck behind the door. Hey, no, no. Back away. Back away, mate. It's not for eating. Come on, out from underneath the chair. Come on. Right. Oh, I don't want that. I was lost where I was doing then. Oh, you can see what I was looking for on Amazon, can't you? Yes, right. So we're turning the green one on. Oh, I don't know what's got into him. Right, green, green. Dude, what's the matter? You can ban people from your iPhone, yes. Yes. Or it is shift when you need it. Is that the... Oh, or is. Okay. Or is. Okay, I get what you're saying. Right. So we need to set the to be outputs. Okay. And set them to be outputs, yes. Yeah, I saw the trailer, mate. I saw the trailer. How can an 80-year-old do them sort of things? Ugh. Oh. Dude, no. Come on, out. Come on, out. No, not underneath the chair. I don't know what's going. What? They made 3, so we don't need 4. Did they make 3? I thought they made 4, and this was number 5. He's going to bang his head against the door. I can see it coming. Let me just put the door to one side. Hiding in the fridge to protect himself from a nuke. Yes. Yes. Come on. Come on. Come on. Say hello to your door in public. Yeah? Say hello to your door in public, yeah? There you go. Oops, wrong one. There you go. Say hello to your door in public. Say hello. By the way, this is him shaking, not me. Say hello. Say hello. Yeah? Hey? Hey? Are you judging my code? Are you judging my code? Well, don't judge me. I didn't write it. Like his jumper. They've both been to the groomers, so they're a little bit cold. Who am I talking to? Yeah. Are you all right now? Have you seen what's going on up here now? Yeah, you don't need to get underneath the chair anymore. Yeah. Yeah. Hello Raiders, welcome. Ditch the jumper for a cape. Well, to be honest, mate, it's almost cape-like. Oops. Look, it's almost cape-like. Oh, is that upset you now?
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh dear. You press that button again.
Hi, John here.
Hey.
Another subscriber. Stay a while. Stay forever.
Oh dear.
Hi, John here. Another subscriber. Stay a while.
Been done in your
Stay
name.
forever.
Been done in your name. Come here. Lie down. Lie down.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Yeah.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Yeah, they don't work on that. I ain't put the on. I can hear it though. Docster, you can't blame Nico for that. His ears laying down, look. You can't blame him for that. You can't blame him for that. Next time it's probably Aston. You alright? Alright then, let's get you down on the ground. Yeah? Yeah? Here we go. Get your feet. Get your feet. There we go. Thank you, Docster, for the 4 gift subs. As always, much appreciated. And don't blame Nico, he was in my arms at the time. Hello, Raiders. Who's raided me? Oh, Gay Game's wife. Hello. Hello. Welcome. We are messing around with a bit of C++ and the Pico. Well, there we go. The Pico. We are messing around with a bit of C++. Right, so where was we? Oh yes, we are converting this. So button 1 and button 2 is green. Okay. Then button 1 on its own. Okay, button 1 on its own is amber. Right. And Nico's falling over again. Oh, that's not right. So yellow LED, and the last one is when nothing is pressed, we go to red. I wonder how you press 2 buttons at the same time in the simulator. Yes, that's not, unless you put them to both the same key. But that's not going to work, is it? Come on, dude. It's going to make me go grey, he is. It's going to make me go grey. And we turn the buttons off. attach a second mouse to the PC. Right, and then we make these low. So that is essentially this. And Nico is pacing. Right, let's see if that works. So it should be red all the time. There you go. Red is on. Red is on. Right, so if I press 1, the amber is on, but the red stays on. Right, if I press 1 and 2, oh, it works, look. But that shouldn't be doing that. If button 1 and button 2, it's keeping its state. But that's what would happen here. There's no clear out. There's no clear out, is there? No, mate. Come on. Out. No. Back up. Come on. Out. Come on, mate. Out. Not in behind. Not underneath the chair. Come on. So there is a problem with this. There's a problem with this code. There's a problem with this code because it's not setting the red to be low when the other two are on. Right. To light the red and turn off the others. If nothing is being pressed, button 3. Yeah. So red needs to be. Everything needs to be set to low. I don't think. Yeah, he is. He's heading for the naughty step. I don't think he needs to go out because you would be hearing him going. Arr, arr. I think it's roughly about 2 hours since he's had his meds. And his meds make him go all dizzy. And I think that's probably what's the thing. He's just wandering. Right. Okay, so we need to check. I mean, the state's clearing, right? 1. Whoops. No. 1. So the state's clearing, but yeah, the state's not clearing, is it, for the amber light and the red? Right. Hello, Gmstad, welcome. Well, I've just put an else. I'll put an else. You won't. I'm going to say, if you put an else against there, you're not going to set the red, right? You're not going to set the red. So what you have to do is, we have to do this to be absolutely sure. Come on, Nico, out from underneath the chair. You're going to hurt yourself. Come on. Ooh, have I got me? There we go. So this should now sort it, because we're at. He's just walked into a door.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Hello, who's just followed? Say hello. Say hello, don't be afraid. Don't be afraid. I missed the alert. Say hello. Oh, I don't know where the Twitch bit is. Oh, there's Twitch. Haha. Who was it? Gigabates. Welcome. We've built it. We're learning with buttons now, but we found Nico, come on. Just lie down, mate. Lie down. Come on, lie down. No, 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 no. That way. Come on. Right. We found a problem in the code that it's not, even here, it wouldn't clear it out. Because if button 1 or 2 are pressed, then it turns the green light on. But there's nowhere to turn, I mean, it doesn't turn the red light off, does it? It doesn't turn the red light off at all. So there is a bug in there. There is a bug in there. So now we should be working. So so red light's on. So if I press 1, whoops, got to make sure I'm on it. There we are, amber light's on and the red light goes off. And then 1 and 2, there we go, red light. Right, that sorted it. That sorted it. Oh, okay, SP. Okay, okay. It doesn't. Does it not say it? Let's see. When using nails to light the ready D. Okay. We use the end to check button 1 has been pressed on its own. Then, if so, the amber. Yes, it doesn't say, does it? It doesn't say anything turns off. It doesn't say anything turns off. Oh, okay. Okay, that means the red light's on all the time. Okay. Okay, right, okay. So what's the next activity? Activity 4. I thought we'd done 4. Oh, hang on. This is not activity 4, is it? It's activity 3A. There we go. Email Pie Hut. I'm not going to email Pie Hut. Right, what's the... So activity 4. So we've got another activity. Activity 4. Here we go. It doesn't say it stays on either. Okay, we've been picky now. Right, let's create another one. So let's rename this one. Let's create another one. New file. Activity 4. Yes. So we'll grab... Oh. Where's activity 3A gone? Oh no. Well, that was pants. Are you wanting wee-wees now? Alright guys, I'm just going to take him out. I won't be a sec. Oh, put him in his bed and he's just come out. Now he's underneath the chair again. Out. Come on, out. Come on. Right. Bug in the simulator. Don't rename a file and without saving it. Oh, right. Let's redo it quickly while we've got while I've got it in my head. Nico, get out from underneath the chair. You're gonna hurt yourself. It's green. It was green, wasn't it?
Hello, John here. Thank you for following. Hope you enjoy the stream.
Say hello, who followed? I don't see the thing. Oh, that's not good, is it? Hello, welcome. Say hello to our new follower, guys, while I figure this out because of me not paying attention. Right. That should be working now. Oh, I need to set them to low, don't I? If we go by the code. Right, let's just check that out. Let's just make sure that that's right. Oops. Oh. That's interesting. Oh! That's interesting. Right, we'll get rid of that. Right. I think the simulator's got a bit screwed up. Let's close it, go back into it. Right, let's see if it's still linked. Right, save. If I save it, that has still got KK and that hasn't. Right, okay, it's no longer linked. Oh dear. That was strange. Right, activity 4. What are we doing in activity 4? Right. What are we doing in activity 4? Another trick we can use is the button. Another trick we can use with the buttons and the if statement is to use or between the conditions to check if one of our buttons is being pressed, but make them all trigger the same result. Oh, okay. So, or is that. So button 1 is on, button 2 is on, make it go green. Delay 2 seconds. and then turn it off. I break the IED, yeah, I do. Right, so that is essentially what they're saying. So if one or the other button is there again, Nico, get out. Come on, out. Out, come on, out. You're going to get hurt, come on. That way. The escape artist has stricken again, haven't you? You've managed to get out your jumper again, haven't you? Alright, there you go. Come on, out from under. Come on, you're going that way. Go on. That way. Oh. You never liked that top anyway. Escape artist. Escape artist is... it's ridiculous. Right, buttons 1 and 2. So 1 makes it go green. Right, let's... oh, he's back again. Right, 1 makes it go green. And 2 makes it go green. Okay. Okay. Let's rename this. Let's do activity 5. Right, what's activity 5? Well, there was a lot of activities for this one, isn't there? Right, what are we doing here? Another handy feature is to use the GPIO's pins is to toggle. As you might have guessed, this toggles a pin status from high to low and low to high. The example below is mostly used button 1 to toggle the red LED on and off. Yeah, we don't need that. Day 3 is complete. I mean, we can do the toggle. I mean, that's going to be a no-brainer. That's going to be a no-brainer, really. Let's just make sure. So button 1, and we're toggling red. Okay. So button 1. And we're toggling red. Well, we know how to do that because we've done that before. Red, not digital, read, red, LED. Is that what it's doing? Yes. So we don't need that either. So this is just now toggling when we press button 1. So when it runs, we press button 1, which is the green. Button 1, which is the green, red goes on. There we go. And then it goes off. On, off. On, off. So we haven't got the thing called toggle. We haven't got that code, but we can simulate it by doing this. So that's day 3. Day 3 is done. Nice. Right then, what's day 4? What are we doing in day 4? I haven't seen these, so right, let's do day 4. Oh, there it is. Alright, FaiRLane. Someone pressed your sleep mode. Night night, mate. We'll talk to you soon. Right, day 4. What are we doing on day 4? Well, really, I ain't even done physically day 3. But I do. Should I do it? Don't know. How many cables have we got? So we have 1, 2, 3, 4, 5, 6. Oh, so we got enough cables. This is easier in C++ than MicroPython. Yeah, it's the MicroPython has the libraries, I suppose. But we have to write them, yeah. But I'll do the physical. I'll do the physical thing tomorrow. Right, what's next? Oh, got the potentiometer knob. Potentiometer. Day 4. There we go. 1 potentiometer. And some cables. But we'll do it virtually. I'll do it physically later. But my homework is going to be interesting because I wasn't sure. I wasn't sure if any of the activities was going to be the homework, but it looks like it's not. So that's going to be even better. Right. So what we're doing here. What is a potentiometer? It's a variable resistor. Well, we know that. So the potentiometer in the box is a 10k potentiometer, which means that it can set between 0 and 10,000 ohms. Right, okay. The way we're going to wire up our potentiometer allows us to send a varying voltage value to our Raspberry Pi Pico. She's starving. Python looks like modular 3 Pascal. I can see where you're coming from. I think it's more basic like than anything else. I can see where you're coming from. So we're still using the LEDs. Oh, that's all right then. Right, so grab the potentiometer, slide it on the board. Oh, right, so we're putting it on the board, are we? Right. Okay. Right, what I'm going to do then is we're going to save a copy. I'm going to call this day 4. And we'll leave we'll delete that. We'll delete that. No, we'll delete 4. Get rid of that one. Get rid of that one. Get rid of that one. No. That one. John, get your numbers right. And we'll rename this. No, don't want to delete. Rename. Day 4, Activity 1. Right then. So we are taking these out and we're going to be adding a potentiometer. Right, let's add a potentiometer. Have we got a potentiometer on here? Yes, we do. Get in there. One potentiometer. Now, what's that set to? No attributes for it. Okay. Right, let's see what they want us to do with it. Put it on the board. Right, so the right pin needs to be connected to 3 out. Okay. So we'll move this to the bottom. Seeing as that's how it's got it laid out. So the right pin needs to be at pin 36. That's that one, isn't it? Pin 36, 3 volt. Yeah, 3 volt. So we are taking one from there and we're putting it in there. I think that's what it said, isn't it? The middle pin goes to pin 32, GPIO 27. There. Goes to there. And the left pin goes to ground. Okay, so we'll grab that one and we'll put that there. So this is going to be power. That's ground. So this is our number. Yeah.
Oi, John, pay attention to chat.
Don't. Oh, right. Check the label on the pot. Right, okay. So we've done that. Right, so let's start a simple program that continually prints the analog readout from the potentiometer. We're specifically reading GPIO 27. This is one of the Pico's ADC pins. But what's an ADC? Well, I think I know what it is. ADC pin, if you're looking at the Pico map, there we go, Pico map, 27, ADC 1. The dark green ADC pins 26, 27, 28, 31, 32 and 34. ADC's analog to digital converter. The ADC pins on the Pico have the specific ability of being able to convert an analog input into a digital form that we can use. We have to import the ADC into our code to use the feature. Right, that must be the MicroPython library. Okay, so the read U16 does. Oh right, okay. The code below imports the ADC set to pin 27. We're going to start with a while loop that prints the potentiometer value every second. The read U16 part does this, taking the varying voltage applied to the pin from the potentiometer and scaling this to a range of usable output between 0 and 65,535. For those who want to get technical, yes we do. The Pico ADC pins are 12-bit pins. Hang on, but 65535 16-bit. Oh, however, MicroPython scales this to 16 bits range, which is 0 to 65535. So 12-bit will be 0 to 4095? Is that right? Two. Oh, we're in programmer mode, aren't we? Right, clear. 2 to the power 12. Yeah, 495. Right, 0 to 495. Okay. C's 1024. Is it? Right. So, the code. Right, okay. So, we are setting pin 7. Right, so I presume we're setting pin 27 to be an input pin. I assume. Right, let's so I assume that we're... Oh, I can't do that, can I? You don't need to for analog. Oh, right, okay. So you reckon it's analog read, do you? Okay. Let's find what analog read's all about. Analog read. Reads the value of a specific analog pin. Arduino boards contain a multi-channel 10 analog blah blah blah. Right, on the Arduino, for example, this yields a resolution between readings of 5 volts in 1024 units. Oh, okay. The input range, right. The input range can be changed using analog reference, while the resolution can be changed only from 0 due to the MQ. So we could change the resolution, yeah? We could change the resolution to go to 4096. Couldn't we? The default analog read resolution for these boards is 10 bits. You would need to use analog read resolution to change it to 12 bits. Okay. Oh, so we put the number of bits in. Okay, so let's do that. Let's mirror what we've got. 12. So that should give us a number between... Right, so we should be able to do this. So we're going to need to do analog read, and it is pin 27. Right, try it. See if it works. So we're on 0. Let's... Hey, cool. Is it 2 to the 13 minus 1? No, it's 2 to the it's 2 to the 11 minus 1, isn't it? 0 to, well, it's 2 to the 12, isn't it? 495. 12 bits is 2 to the 12, which is 496. So that means it's 0 to 495, isn't it? 12 bits. But it's doing it, it's reading it. And we get 495. And we get 0. That is so cool. That we can read an analog signal without having to do any jiggery pokery. That is so cool. Right, what's next? What's next? What do we need to do next? It will go to 16 bits. Yeah, but if we want to use native, they said it was only 12 bits. So it would be upscaling, wouldn't it? It'd be upscaling. So basically shifting. It'd be shifting, wouldn't it? Right. What's next? Oh, activity 2. Control flashing with analog values. Okay. Okay, so rename that. New file. We'll grab all that lot. Right, what are we doing? So we can do this with large range input readings. One of the things that we can do is to use it in our code to control other components such as LEDs. Whereas previously we have turned LEDs on and off with buttons, the wide range of output readings allows us to tell our code to do different things depending on what the range is. Okay. Yeah, if the Pico can only do up to 12 bits, and if you go up to 16 bits, then basically it's upscaling, which means it's just going to do a logical shift, isn't it? If there's only 12 bits of data available, you put 12 bits onto 16 bits, there's 4 bits that will have no information in it, because that's what upscaling does. It's my understanding of upscaling anyway. Let's turn that off. Right, so variables for time delay. We use a variable to make a counter. Yes, in day 2, yes. Right, for example, blah blah, we had 5 LEDs, delay, 1 flashing. Right, what we're going to do? Oh, we're going to use the potentiometer to vary the delay. Okay. For example, take the reading of the potentiometer, divide the reading so it gives us a number that's more usable as a time delay, assign the divided reading to my delay, use the delay variable to control how long the LED is on and off for. Oh, okay. We can do that. Right, so which LED are we going to use? Or does it say? does it say? Which one? Red. We're using the red one. Right, so let's turn the red one on. Right, where's the code? So we've turned it on. We're going to have a variable called my delay. Right, so we read, right, we're going to read, so we set the resolution. So we're going to read the pot. So let's have a look. So they're dividing it by 6,500. Variable is out of scope. No, it ain't. It's a global variable, mate. So let's do what they're doing. So they're dividing it. So if we're 4095, let's divide it by and then, all right, so so they're doing that. Okay. I'm just wondering if that's flashing too long. Because it's just on permanently. Okay, let's do that. There we go. Right, it's flashing now. Now that's flashing. That's flashing, but it's on permanently. And then it gets longer. There we go. Yes. Good spot, mate. I forgot they were working in seconds and we're working in milliseconds. Right. Okay, so that works. So now we're controlling the flashing LED by our potentiometer. Nice. Right. Activity 3. Light LEDs depending on the potentiometer value. Oh, okay. Alright, okay. Right, there we go. Let's save this. Rename to .text. I'll stop that. Save. Create a new file. Activity 3. Might as well grab this. I wonder if Control A works. Yes, it does. Control V's copying it. Oh, no. Right, so what are we doing now? For example, below, we use if statements to check the readings is less than 20,000, less than 40,000 or greater than 40,000. To make the statement look, we are using the less than operator. So it's just an if statement, is it? Yes, it's an if statement. Right, okay. So we're going to do the same thing. So we're going to take the reading. So we're not using a delay. We're going to sleep. So delay for 100 milliseconds. Because they're sleeping for 0.1 second. Then we're going to do the tests. Right. Okay. If. Right. I'm just going to move this to this side so I can see it. Right. So if reading is less than or equal to, say, so we got 3 bands and 4,000, so that's 1,200, isn't it? Less than 1,200, then we are going to set the red LED to be on, but we need to turn the what? But we need to turn the other ones off. Yep, right. Then else if reading is less than 2,400. Ooh, right, low, 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 low. Then else well, I'm pressing all sort of buttons here. Right, stat bats, hopefully you'll be able to do all this soon. Hopefully, right, we need to print the reading out. Alright, Nicomo, thank you very much for joining. By the way, thank you for the goodies that you sent me. I will be playing with them. GaryMeg's already got me set up so I can play. Right then. Night night, mate. Right, let's see if this works now. So let's press. So we're going to get the number. So 125 should be red, which it is. So as soon as we go above... Oh, hang on. Have I set the resolution? Oh, I've still got it divided by 4 like a Wally. Plank. There we are. So green. Amber. Red. So red to 1200. Then it's yellow to... Yeah, that's right. They're the three thirds. Nice. Nice, nice, nice. Right, so that's that one. Oh, we're motoring through these ones. Oh, it's over here, isn't it? Right, what's next? LED fading. LED fading. Now for something a little bit more advanced but really cool. We are going to fade an LED in and out using the potentiometer. We need to use the light. Oh, I suppose it's a different library. So PWM stands for pulse width modulation. Okay. It's a type of digital signal where we over a set period of time decide how long the signal is on and how long it's off. This very fast on-off signal can create fading effects on LEDs. Okay. We can decide how long by changing the duty cycle. Okay, well we're not. So, okay. So we need to find the equivalent. Right, so this is activity 4. So let's rename this. And new file. Do the same as before. No. No. Thank you. Analog write. That is all you need. But that's not a pulse though, is it? That's not a pulse. I thought they were talking about pulsing. I suppose they are because they're doing this duty. Oh, it's a different library. There's no actual analog output. Oh right, okay. Well, I bow to your superior intellect, my friend. So let's try it, shall we? So, which LED were they talking about? Which LED? Pin 18. Pin 18 is... that's red, isn't it? Yeah, pin 18 is red. So we'll active, or red's activated anyway.
Oi, John, pay attention to chat.
It's actually analog right. Oh, yeah. So set up red. So we'll get rid of this. Oops. Put that back in. And so you're saying analog right. Okay, so we'll do that. So we'll print the reading out and then we'll set the LED. So analog right. Red LED, comma, reading. So that's basically what you're saying it is. Okay, let's try it. But the red LED is not coming on. It's not actually coming on, mate. Now I thought, because I've been looking at this because of the buzzer, because of the homework, I thought it would be this. Yeah, but it's still a square wave though, isn't it? I thought it was still a square wave. Right, the LED's on, look. Now it's off. But that's almost straight away, so it can't, so it's not. I mean, it does fade. It does fade, but I think we're going to have to do this. Let's try that. It does fade, but the... Right, so we're going to have to make it a big number. Oh, we're going to have to make it a big number to try and extend that term. Alright then. So maybe the number was too much for the analog right. It's not doing it. The duty cycle has to be between 0 and 255, but what's the duty cycle? Oh, hang on. Look. Analog right is between 0 and 255. So, right, we've got to divide that. 8. $16. Right, so now we're doing the proper right, but what's the duty cycle then? How do we set the duty cycle? Oh, okay. So the bigger the number, the higher it's on. But the red light's not flashing. Have I got this right? Set red. Set. Do I need to set it to be an output? No, it's not doing it. This is something we're going to have to do on the real kit, isn't it? This is something we're going to have to do on the real kit because this doesn't seem to be working. Maybe the simulator can't simulate this. How do we set the frequency? How do we set the frequency? Okay. No. No, it doesn't seem to work. So I'll have to do it on here. I'll have to do it on here. Let's build it up. Let's build it up. Let me put the buttons away. And we'll try it on here. Right, so that's day 3. We're on day 4. Right. Right, let's I presume we have to build this up, do we? Put the washer on and stuff? Do we? Right. Let's put the pins on. So brown is live. Right. So, connected the potentiometer up. So we are putting it on pin. Right. Live. So we're talking the bottom, aren't we? This is the bottom. Because we did the bottom, didn't we? So, So, 1, 2, 3, 4, 5th one in. One, 2, 3, 4, 5th one in. Get in there. It don't want to get in. 1, 2, 3, 4, 5. There we go. That's in. Next one is 4th one after that. One, 2, 3, 4, and then the next one is after. Oh, I'm already using it. So I'll have to nick another one. Where's another ground around there? There, next to it. Right. Right. So that goes to power. Let's turn that way. Right, so we should be on red. Right, let's copy it. So let's grab this and we'll go here. Right, so we're on day 4. So day 4 activity 4.ino. Right, so that's basically what we're doing, yeah? So Pico on. Yep. Right. Go. Okay, why are you doing that? Oh dear. Why are you doing that? I don't want you to do that. I want you to do what I'm doing. Can't stop it either, can we? Can't stop it. Right, let's see. Come on, have you uploaded? Apparently we've uploaded. Or have we? Oh, there you go. You watching? So he's doing it. Right, the camera's a little bit... But if I do that and put it that way on, right? Now watch. See, it is fading and then gets brighter. At least it didn't go boom. But it's doing it, look. So it's going, it comes in, it fades in, and then it gets brighter. And then fades away. Right, so that's something that the simulator can't do. Ah, right. Is that because of that? Right, okay. I will do something with that. So that now shows that the simulator can't reflect everything. Because the simulator's not working for this. Well, that's interesting. That's interesting. Right. So I think that's it. I think that's what we've done. Day 4. So we've messed around with potentiometers. Right. So homework. Don't use workspace for Arduinos unless you've got multiple files. Okay. Okay. I'll remember that next time. Right, homework. So the homework involves the button. The homework involves the button. We are going to take our traffic lights, and we're going to add the button that allows a pedestrian to stop the traffic lights, and then I want 2 extra LEDs to represent the pedestrian traffic system, that when you press the button it stops your traffic light, and then the pedestrian traffic lights kick in that says for the person to cross the road, and then when that traffic light's gone back to red, it restarts your single traffic light. That's the homework. That's the homework to it. Now you've done that. Now we're going to add the button to it. We're going to add the button to it. Are you all... Do you understand the homework? Do you understand it? That's the homework. We're going to, from what we've learnt with the buttons, we're going to add more functionality to this traffic light to allow pedestrians to simulate crossing the road. Yeah? I have no idea if anybody's there. Where's my YouTube? Twitch, where's Twitch? Well, 10 people on. Do you understand the homework? Just type in notes. Right. So I will probably back on Wednesday. I'm disappearing to the coast. I'm disappearing to the coast. Oh no, I'm not. Yeah, I'll be back on Wednesday. So Wednesday we'll be doing days 5 and 6. Now, like I say, I'm not looking at the days. I'm resisting looking at them so we can do them on stream, and then I will instantly try and work out the homework. But I knew because the thing we had buttons, I knew what the homework was. So that's what the homework is. I want you to add 2 more LEDs and a button to represent when somebody wants to cross the road and needs to stop. Doe, you're away this week until next Friday. Hey, Mikroman, I'm just about to wind up, mate. I'm sorry. I'm sorry, mate. I'm just about to wind up. I'm just setting the homework. I'm just setting the homework. So if you're interested, we're messing around with a Pico. We're messing around with electronics, and we're doing the advent calendar of the Pi Hut. But we're writing it in C++. So here's an emulator that allows you to... you was looking forward to play on a Beeb. You are away this week until a week on Friday. Oh, right. All right. So, because I'm thinking of going to the coast this Thursday, Friday. Well, I'm off, so I could put the. Yeah, it'll have to wait until I open up, mate, and then we'll organise me fetching the Beeb round. Yeah. Right then, so that's the homework. I've got like 2 just for the people that don't know, I have got a Raspberry Pi Pico channel in Discord, and now we have a homework channel where you can post your homework if you're using the simulator. Alright, so like I say, homework is to take your traffic light system and add a button to allow us to halt the traffic light for pedestrians to cross the road, and have an indicator to let the pedestrian know that they're crossing the road. That is the homework. Alright, well, thanks for joining me. That's days 2 and 3 and 4. That's it. Days 3 and 4. Yeah. So that's Advent Calendar day 3 and 4 done. Next stream on Wednesday we'll be doing days 5 and 6. And we'll see what we can blow up now. Alright? Well, thank you very much for watching. It's probably been a boring stream, I don't know. It's been interesting for me. Alright. Well, guys, I will see you on Wednesday. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.